Hello, this is a lesson on how to find the solution set to a quadratic inequality. We will list the answers both in interval notation and also set builder notation. Before I show you an algebraic way of doing it, I'm going to show you a method on the table on your graphing calculator that can help you notice where this quadratic inequality will have values that are less than 0, or in essence, numbers that are negative in value. This is a quadratic inequality because the highest degree is a 2, and we have an inequality symbol, not an equal sign there. Right, so what you want to do first is take your graphing calculator and enter in the inequality, the quadratic portion, for y1. Next, we're going to make sure our table set up, so press second window, and you can start it from 0, go up by 1, and make sure both of the variables are on auto mode, so they'll generate everything for us. Press second graph to look at the table. Notice how all these are positive. Those are not the numbers that would be less than 0. So as I scroll upward, I start to see some negative values. I can clearly see these outputs are negative, but what I'm not sure about is, are there any outputs between 0 and -3 that I just can't see yet, and also between this -3 and that 0. So I'm going to change my table to look at some decimal values. So I'm going to go between the -3 and the -2 to start. So press second window, and I'm going to start from -3, and I'm going to have them increase by 0.1. Press second graph once again, and now notice between the -3 and the -2, there were a number of negative values we just couldn't see. So I want to make sure that my solution set goes up to the -3, but doesn't actually include it because 0 is not negative or not less than 0. And then on the other side, let's start it from 0 and see what happens between 0 and 1. So notice between 0 and 1, there's also a whole bunch of negative values we couldn't see. So just like on the other end, we want to go up to the 1, but not include it because its output is not a negative value. So we pretty much know the solution sets going from -3 to +1, we're just not going to include them. The way we would write that solution set, in interval notation, always start from least to greatest. So we'll go -3 to +1. And the way you show that they're not included is we use parentheses next to each number. If they were included, we'd use a bracket. For set builder notation, this would be the set of x's such that -3 is less than x, which is less than 1. So we want all the x values between -3 and 1, and we're not including them, so there's no equal to line there. So that is a way to identify the solution set using your graphing calculator and its table. But there's an algebraic method that we can use just as well. So for the algebraic method, here's your procedure. You first want to find the zeros or the roots algebraically. So we'll factor this, and when you're finding roots, you set equal to 0. We'll do x plus 3, x minus 1, which will now give me roots of x equals -3 and x equals +1. That's the first step. Now we want to put these roots on a number line and figure out if we should use open or closed circles. This inequality is pronounced less than. So since it's less than, we don't want to include our values, we want to be lower than that. So to show this, you would use open circles to demonstrate that. So on the number line, we list these values from least to greatest. So -3 and 1, and I always like to put -infinity on the left and +infinity on the right. I'm going to use open circles since we're not equal to on the inequality. Now for the most important step in the procedure is step 3. We want to use a test value in each one of these 3 sections to see is it true or false and will it be a part of the solution set. So you can use nice easy values here, and I always like to have my students list the values up top so I know what they actually plugged in. So you can use any number between -3 and -infinity. I'll use something like x equals a -5. Between -3 and 1, a nice easy number to use, x equals 0. And then anything between 1 and infinity would work. I'll keep it simple and use x equals 5. So now we go to our graphing calculator. We want to compare the left side and the right side on the graphing calculator with a less than symbol. Okay, so the quadratic is already in there. I'll put 0 for the other side. Adjust your table. We'll start from 0. We'll put a 1 there. But this time I need you to put the independent on ask so we can put in whatever values we want to. So go to second graph, and notice we can now put the numbers we want in, which were -5, 0, and +5. Now remember, I don't want you drawing on your calculator screen, but what this is saying is 12 less than 0? No, that is false. Is -3 less than 0? That's true. And 32, is that less than 0? No, that is false. So for our sections, we know it goes false, true, false. False, true, false. The areas that have the true, that's what we want to highlight because that's where your solution set is going to fall between. So for integral notation, just as we did a moment ago, we go from least to greatest, so -3 to 1. And because those are open circles, not including those numbers, this is a visual way of knowing why we want to use the parentheses and not include them. And the set builder doesn't change at all from before. The set of x's such that x is going to be between -3 and +1. Okay. And actually that was the fourth step in the procedure to write the solution set. All right, so that's an algebraic way of solving the same exact problem we did using a table. Okay, so this would be how you show your work to get your full credit. Another example, for this one you notice it's not in standard form with a 0 over here. So our first step is to bring that over. And writing this in descending order of exponents, we get x squared minus 8x plus 12 is greater than 0. And now we just follow our procedure. We're going to start factoring. So this will be x minus 6 and an x minus 2, which gives us x equals 6 and x equals 2. Okay, we know these have to go onto a number line. So always least to greatest. So the 2 goes here, the 6 goes there, and I like to put -infinity on the left and +infinity on the right. When I look back at the inequality symbol, I notice this is saying greater than. So therefore, since it's just greater than, once again, I'm not going to fill in these circles. I'm going to leave them open. But now we have our 3 sections that we're going to need to test here. All right, so first of all, let's get the inequality into the calculator, and then we'll pick a couple of easy values here. Okay, for the easy values, I need something between -infinity and 2. X equals 0, seems easy. Between 2 and 6, a nice value of 4 should work. And between 6 and infinity, something like 8 would be fine. So now let's go to the calculator and put in the quadratic. So clear these guys out so they're not in there by pressing delete. Go back to y equals. Clear out the previous problem, and let's put in x squared minus 8x plus 12. And you can leave the 0 in there, that's fine. Now when I go to second graph, I'm going to put in those 3 values. 0, we said 4, and we said 8. Now this time, we're using a greater than symbol to compare. So the question is 12 greater than 0? Yes, it's true. Is -4 greater than 0? No, that's false. And is 12 greater than 0? Yes, it is. So that would be a true. So this time we have ourselves true, false, true when we plug on in there, comparing the left side to the right side. So we had true, false, true. So that means my solution set, one's on this side and one is on that side, giving me two separate sections. The way we would identify this in interval notation is we go from least to greatest. So this is my lowest value here, negative infinity, up until 2. Then we have another section, so I'll use the union symbol to identify that, and we're going to go from 6 to infinity. We can never ever equal infinity or negative infinity. They always get a parentheses. And since these are both open circles, we're not going to have them equal to, so they will also get parentheses in this example. So that's the solution set written in interval notation. And as far as set builder notation, it would be the set of x's such that, now the x's all over here are simply numbers lower than 2. So I'll put x is less than 2, or these represent all the values that are bigger than 6. So, or x's that are greater than 6. So that's the set builder notation, and that is the interval notation. So you can get two separate sections depending on how the true and falses lie. Okay, final example. Okay, we're going to start off factoring this once again. But notice this time, this one says greater than or equal to. That will have a different effect for us in this solution. Okay, so we're going to factor this to 3x and an x. We'll put the 5 over here, we'll put the 3 over there, and a negative 5 and a plus 3 will do the trick. Because these inner terms give me negative 5x, the outer terms give me positive 9x, and when you put that together, that will give us the positive 4x we need. So this gives me 3x minus 5 equals 0. If you're not able to do that in your head, that's why I'm showing this work. So 3x equals a 5, divide by 3, and x equals 5/3. You can get a fractional value, and this is simply x equals negative 3. When I put these on the number line this time, we'll have negative infinity, we'll have positive infinity, we'll put the negative 3 and the 5/3 over here. Since this is equal to, we want to include those numbers. So now for the first time, I'm going to fill in these circles to represent that we're including the negative 3 and the 5/3. We're going to pick a couple of easy values here. I'll use x equals negative 5. If you're not sure about the value of 5/3, play it safe. Use something close to this, like x equals a negative 2. And for this, use something that's beyond 5/3, even though it's about 1.6. Okay, you want to go beyond that, so just use x equals 5 to play it safe. Okay, so let's now put this one into the calculator. Clear out these old values. Okay, so this is 3x squared plus 4x minus 15. Once again, the 0 is fine. When you go to your table and we put in our numbers, we used negative 5, we used negative 2, and we used a 5. If we quickly compare now, these have to be compared using greater than or equal to. So notice we get ourselves a true, a false, and a true for that section there. True, false, true. So therefore, this section's in my solution set, this section's in my solution set. So if we go least to greatest here, we're talking about negative infinity to negative 3, or 5/3 to infinity, As I said before, you can never equal infinity, but because these are filled in circles for the first time, we use a bracket to show that they're included. And then the set builder notation, the set of x is such that the x's are going to be less than or equal to -3, or the x's are greater than or equal to +5/3. Okay. So that's how you solve a quadratic inequality algebraically. And not that this needs to be copied down for my students, but just realize you could have also had greatest common factoring involved, or the dots method, or factoring by conjugates as well in this process. Thank you for the video. I hope you enjoyed.